When dealing with the kitchen garbage disposal switch and plug installation where countertop space is limited due to a large window or lack of a wall, several solutions can be considered to comply with the National Electrical Code. Firstly, check if there is enough space under the sink to accommodate a switch and plug. This location can often provide a hidden and protected area for the necessary electrical connections. It's crucial to ensure there is adequate ventilation to prevent moisture buildup and easy access for maintenance and repairs. Secondly, a remote control switch can be a viable alternative. This involves installing a remote control switch that can be operated from a more convenient location, such as a nearby wall or inside a cabinet. The remote switch communicates wirelessly with a receiver connected to the garbage disposal, eliminating the need for a traditional switch near the sink. Thirdly, if a cabinet is adjacent to the sink, consider mounting the switch and plug on the side of the cabinet. This option provides accessibility while keeping the electrical components off the countertop. Ensure the location does not interfere with the cabinet doors opening and closing and that it is protected from potential water splashes. Regarding the placement of two plugs on a kitchen island, the National Electrical Code does not specify a precise height requirement. However, industry best practices and general recommendations suggest installing them between 18 and 24 inches above the finished floor. This height offers a balance of accessibility and safety, reducing the likelihood of tripping over cords while keeping the outlets within easy reach. When replacing a complete service panel with power coming from underground, the primary task involves wiring from the meter to the new panel. The existing underground wiring should already be in place, but it is essential to have it inspected and tested by a qualified electrician to ensure it meets current electrical codes and is in good working condition. The process of wiring a new service panel involves several critical steps to ensure safety and compliance with electrical codes. Firstly, disconnect the power from the old service panel. This is a crucial step to prevent electrical shock during the replacement process. Contact the local utility company to disconnect the power supply to the meter. Once the power is disconnected, verify that there is no voltage present at the service panel using a reliable voltage tester. Secondly, remove the old service panel. Carefully disconnect all the wiring from the old service panel, labeling each wire to ensure correct reconnection to the new panel. Take photographs of the wiring configuration as a reference. Remove the old service panel from the wall, taking care not to damage the surrounding structure. Thirdly, install the new service panel. Mount the new service panel securely on the wall, ensuring it is level and properly aligned. Connect the grounding and bonding wires to the new panel, following the manufacturer's instructions and local electrical codes. Fourthly, connect the main power wires. Connect the main power wires from the meter to the main breaker in the new service panel. Ensure the connections are tight and secure, using the correct torque specifications. Fifthly, connect the branch circuit wires. Reconnect all the branch circuit wires to the appropriate breakers in the new service panel, following the labels and photographs taken during the removal of the old panel. Ensure each wire is properly seated and tightened in the breaker terminal. Sixthly, test the new service panel. After all the wiring is complete, double-check all connections to ensure they are tight and secure. Turn on the main breaker and test each branch circuit breaker to verify that it is functioning correctly. Use a circuit tester to check the voltage and polarity of each outlet in the house. Grounding and bonding are critical aspects of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of shock. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode conductor connects the service panel to the grounding electrode system. Bonding jumpers are used to connect metal enclosures, such as service panels, meter boxes, and equipment housings, to the grounding system. Surge protection is another important consideration for electrical safety. Surge protective devices, or SPDs, protect electrical equipment from voltage spikes caused by lightning strikes, power surges, and other electrical disturbances. SPD are typically installed at the service entrance and at individual branch circuits. Arc fault circuit interrupters, or ASIs, are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. ASIs are required by the National Electrical Code in many areas of the home, including bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. GFCIs are required by the National Electrical Code in wet locations such as bathrooms, kitchens, and outdoor areas. When working with electricity, it is essential to follow all safety precautions. Always disconnect the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work. The National Electrical Code, or NEC, is a set of standards for electrical wiring and equipment in the United States. The NEC is updated every 3 years and is adopted by most states and local jurisdictions. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. Electrical permits are required for many types of electrical work. Permits ensure that the work is done safely and in accordance with local electrical codes. Contact your local building department to determine whether a permit is required for your project. Electrical inspections are conducted by local building officials to ensure that electrical work is done in accordance with the National Electrical Code and local electrical codes. An electrical inspection is typically required after a new electrical installation or when significant electrical work is performed. Proper wiring techniques are essential for electrical safety. Use the correct wire size for the circuit. Make sure all connections are tight and secure. Protect wires from damage. Avoid overloading circuits. Use ground fault circuit interrupters in wet locations. Use arc fault circuit interrupters in bedrooms and living rooms. Regular maintenance of electrical systems is important for safety and reliability. Inspect electrical cords and plugs for damage. Replace damaged cords and plugs. Test ground fault circuit interrupters monthly. Clean electrical panels and equipment. Replace batteries in smoke detectors and carbon monoxide detectors annually. The National Electrical Code provides specific guidelines for wiring a service panel. Firstly, Article 230.70 addresses the location of disconnecting means. The service disconnecting means shall be installed at a readily accessible location either outside of a building or structure, or inside nearest the point of entrance of the service conductors. Secondly, Article 230.71 covers maximum number of disconnecting means. Each service shall have not more than 6 disconnecting means for each set of service entrance conductors permitted by 230.2 or for each set of feeders permitted by 225.30. Thirdly, Article 230.85 addresses surge protection. All services supplying dwelling units shall be provided with surge protection. Fourthly, Article 250.24 covers grounding service supplied alternating current systems. System grounding shall be in accordance with 250.4a on or permitted by 250.26. Fifthly, Article 310.15 covers ampacity of conductors. The allowable ampacity of conductors shall be determined by 310.15 and is permitted or required by 240.4d, 240.4e, 240.4g, 310.15b3, 310.15c, 310.15d, 310.15e, 310.60, and 310.61. In summary, installing a garbage disposal switch and plug without countertop space requires careful planning and adherence to electrical codes. Remote control switches, under-sink installations, and cabinet side mounting are viable solutions. The height of kitchen island plugs should be between 18 and 24 inches. Wiring a service panel from underground involves connecting the meter to the panel with proper inspection and testing of the existing wiring.